A major shift of the next generation science standards is that they're made up of three dimensions: the science and engineering practices, the disciplinary core ideas, and the cross-cutting concepts. Being familiar with each dimension and knowing how they work together is key to realizing the vision of the NGSS in the classroom. The science and engineering practices, abbreviated as SEPs or practices, are always colored in blue. In the NGSS, they are what students do. There are 8 of them, shown here. They represent the actions that scientists and engineers do in the real world. In the standards, they build from kinder all the way up to grade 12, so that students can grow their abilities as college and career-ready scientists and engineers over their K-12 experience. The disciplinary core ideas, abbreviated as DCIs or core ideas, are always colored in orange. In the NGSS, they are what students know. They represent the key knowledge and conceptual understanding that scientists and engineers draw from to make sense of the world. The DCIs are grouped in 4 domains: the physical sciences, the life sciences, the earth and space sciences, and engineering, technology, and applications of science. It's important to note, each DCI can be further broken down into more specific component ideas, which are aligned to each standard. As you can see, there are many component ideas within the DCIs, and just like the practices, they build in complexity from kinder through grade 12, so that students gradually deepen their understanding of how the world works over their K-12 experience. The cross-cutting concepts, sometimes abbreviated as CCCs, are always colored in green. In the NGSS, they are how students think. There are 7 cross-cutting concepts. They represent the ways that scientists and engineers think in the real world, and they are applicable across all disciplines of science and engineering. Like the other dimensions, they also build in complexity from kinder through grade 12, so that students develop as college and career-ready thinkers who are ready to be valuable thought partners in the STEM community. In summary, the science and engineering practices are what students do. The disciplinary core ideas are what they come to know and understand. And the cross-cutting concepts are how they think. The vision for how the dimensions work together in the classroom is often represented as a 3-stranded braided rope, always integrated together, and never taught in isolation from one another. In the braided rope model, the places where the 3 strands connect represent the nexus of the 3 dimensions. That is where we want our students, meaning that in every science lesson, students are doing one or more of the science and engineering practices, building their understanding of the disciplinary core ideas, and thinking using one of the cross-cutting concepts as they work to figure out a real-world phenomena or design solutions to a real-world problem.